Alright, so first off, the theorem itself says the following. So this is called the factor theorem. And it says if I have a polynomial P of x has a factor in the form of x minus k if and only if, and if and only if means that it goes both ways, so you can actually go from one side to the other, if the value of P of k equals 0. Which is the same thing really as saying that if I take P of x, the polynomial, and divide by x minus k, the remainder would be 0. Okay, that's the factor theorem. So it says, obviously that we have a k value that makes the function equal to 0, then that factor x minus k will divide into that evenly. So an example of what you may see, again, this section is just a lot of these theorems about polynomials that help us do things in the end, like solve them and write them as factors. The question is to determine if x plus 2 is a factor of the polynomial 4x cubed plus 24x squared plus 48x plus 32. Okay, so there's the problem. That's when we determine if that is a factor. Okay, so what, we just said, well, if it's a factor, what do we have to check? Yeah, so we need to check, right, that P of negative 2 equals 0. And we just did the remainder theorem, which is all connected, very, very similar to this, that we said, when the quickest way to do this is just with synthetic division. If I take and divide the polynomial by negative 2, and the remainder is 0, it's just got to be a factor. You also could just plug it right in, right, and do the calculation, or I think it's probably easier to divide. So I'm just going to use synthetic division. I guess I don't have any zeros, do I? And this gives us a chance for you to use synthetic division as well. So what's my first step on synthetic division? Drop the 4 down. And then I multiply. And I add. Let's see, so 24 plus negative 8. What's that, 16? I multiply. Add. 48 plus negative 32. That's 16. Multiply. And I add. And look at that. So that says, right, the remainder is 0. So that says then that P of negative 2 must equal 0. So, the answering the question, is it a factor?
Yes.
Yes. Yes, x plus 2 is a factor of P of x. Okay, so that's the factor theorem. Okay, and just a couple, well, quite a bit left to do. Okay, so some other applications of the factor theorem now. That's my section 5. Okay, so the first one is the type of question you have is if you're given a zero, we're actually given one of the zeros, then the question will be to find the remaining zeros. So, question 1 I have is that we're given p of x. Here's my polynomial, which is x cubed plus 2x squared minus 11x minus 12. And we're given that we have 1 0, which is 3. I'm going to find the remaining. So my first question is actually how many zeros, what's the maximum number of zeros on this? The maximum is 3, right? There may be 2 more. Okay, so what's the first step in doing this? We already have, well, yeah, we already have a 0, right? So I can divide by the given 0 and reduce it down to a smaller polynomial, right? So really the first step I want to do is divide by, let's divide by the given 0. And that will reduce it to a lower degree polynomial. And again, since these are linear factors, we can always use synthetic division on this. So let's try that. So what goes out front? Just the 3. The 0 goes, make sure you, and that's very easy to mix up. So you're going to practice that, especially for the next test. That's always the 0 out front. Let's see, the coefficients are 1, 2, negative 11, negative 12. Okay, first step would be to bring down the 1. Multiply, add, multiply, add, multiply, and look at that. And it works. Now, the nice thing here is that we expected this to happen, but what's left here now? Yeah, we have a quadratic, and we love quadratics. All the polynomials, we love quadratics the best. Why do we love quadratics? Well, we love quadratics because we always can solve them. Once we get down to a quadratic, we always can either factor it. That's the easiest. But if it doesn't factor, or we don't see that it factors easily, we can always use the quadratic formula. So always try to factor first. Yes, we see that, Cole. Always try to factor that first, and then if it does, use the quadratic formula. So what's this factor into?
1 and 4.
It would be x and x. And what, plus 1 plus 4. So in fact that means then the zero product property says that either x plus 4 equals 0, or so x equals negative 4. The question said find the remaining zeros, so the remaining zeros are negative 1 and negative 4. That's the remaining zeros. Okay. Okay, so that's one example. Example 2. Very similar type question, although I want to do it because it's, the end's a little different, so a little different twist on the end. So in question 2, again, we're given a polynomial, so p of x this time is equal to 3x cubed plus 5x squared minus 3x minus 2, and we're given that negative 2 is a 0. And same directions, I want to find the remaining zeros. Bless you.
Bless you.
Thanks.
Okay, so again, we're going to start just like last problem. We'll take and divide by our 0. So what goes out front? Out front would be the negative 2, right? And because always a 0 out front. And then the coefficients. Again, looks like I'm not missing any, so no zeros. And let's do that algorithm. Bring the 3 down. Negative 2 times 3 would be negative 6. And let's carefully add. 5 and negative 6 is negative 1. Negative 2 times negative 1 is positive 2. And 2 times negative 1 would be, again, positive 2. Obviously, if I don't get a 0 for the remainder, I know I've got a problem, but I did. And so,
If you don't get a 0 as a remainder,
then you have a mistake unless they gave you a wrong problem. Because it already told me that negative 2 is a 0, right? So it said that it has to be a 0. Yeah. Okay, so now I've got this again, it's a quadratic left, and again, we love quadratics because we can solve them. We know we can solve them. We actually have very easy methods for solving. 3x squared minus x minus 1 equals 0. And then you ask yourself, are there any factors of 3 and 1 that add up to be 1? And that's a problem. There actually aren't. So that means, you know, this doesn't factor. And I always suggest don't spend a lot of time factoring, because even if they do factor, you can always use a quadratic formula on them, even if they did. So doesn't factor. Which means quadratic formula. Remember that on the formula sheet, if you don't have this memorized, you probably do, but on the formula sheet you have on the test, it does have the quadratic formula. So, let's see, what is that again? Let's see, negative b plus or minus square root, right, of b squared, 4ac over 2a. And usually the mistakes I see with the quadratic formula have to be with the simplifying. So, it's going to be, alright, so what's negative b? Opposite of b would be 1. And then negative 1 squared is still 1. 4ac. So I get 1 plus or minus. And this actually is 1 plus 12. That would be the square root of 13. 6. And then does that simplify? And it does not. So I have 2. I'm okay with you writing these like this, although I don't know what I'm guessing maybe my math lab may not be, so you may have to write this as 2 separate ones.
There was a simplified.
There wasn't? Okay, so there's that one. Questions on it? Okay, I've got one more type of question. So let's look at that.
On MATLAB, can't you just write plus or minus in between those and we'll take it?
It might. Yeah, I mean it might.
Okay.
I don't. We've had a few instances where it's kind of picky about things, but yes, I would hope that would. Last question. And this type of question, again, I don't remember on the assignment, but is factoring the polynomial into linear factors. So I'm going to put this as a B. So factor P of X, whatever P of X is, into linear factors. Okay, remember that the form of a linear factor, so linear means that, of course, the linear part means that x is to the first power, so just an x. X to the first, it could be ax to the first plus b, that's a linear factor. And a linear factor always has the form of x minus the 0. So if we have the zeros right, we can easily find what the factor is. It's just x minus that. So these types of questions, this question here, number 3, same setup. You're given a polynomial. So in this case, we're given that P of X is 6x cubed plus 25x squared plus 3x minus 4. And also given a 0, we have a 0 equal negative 4. And the direction on this, so of course, is going to say to factor this into linear factors. Okay, well, to do that, I guess first off, how many linear factors are there going to be? If we have an x cubed, it has to be 3 of them to get the x cubed. We have one of them already. We know it has to be x plus 4. Same type of thing. You're going to first off find the other zeros before you can do this. So, to do that, again, synthetic division, the 0 up front, coefficients are 6, 25, 3, negative 4. 6 comes down. Negative 4 times 6 is negative 24. We add. We multiply. Add. Multiply. Which leaves me with this quadratic again. So I'm glad it's a quadratic. That helps a lot. Oops, I forgot my x, and I want x. Now, although this one may not look like it, and if you didn't see it, you actually could use a quadratic form. This one actually does factor. If I have 3x and 2x, if I have a plus 1, the outside is positive 3x, and a minus 1, the inside is negative 2x. Now, I actually can stop here because these are linear factors. Because the x is to the first power. Now, the zeros, right? The zeros would be 1/3 and negative a half. And if I wrote the factor as x minus a third and x plus a half, that would actually be the same thing. Although we often don't like to put the fractions here, but I probably would accept those. The question, though, asked me to write the polynomial as a linear factor. So I'm going to have to write like this. P of x. The very first 0 was negative 4, so that factor is x plus 4. Then I have 3x minus 1 and 2x plus 1. And this then, this is a product, or all multiplied, of linear factors. Which numbers?
Like the x plus 4 and 3x minus 1.
So these from when I factored this, right? This was my quotient, and then I factored it here to this. And those are my linear factors now.
Yeah, what is x plus 4?
Okay, that comes from my original question said that negative 4 was a 0. So then it has to be x minus negative 4, which is x plus 4. Okay, good. Good question. Other questions? Okay, almost.